Good morning to all. Today's topic is laws of probability. In this today, we are going to see about how many laws we have and related to that problems. Okay, we have totally 10 laws in a set identities. So, what are all the 10 laws means? Identity law, domination law, idempotent law, inverse law, double complement law, commutative law, associative law, and distributive law, absorption law, and De Moivre's law. Each we have a two set of formulas, but only in the fifth double complement law we have only one formulas. So what are all that formula? Is nothing but identity law, but everyone has studied this law, but without the name. For example, in identity law, so in identity law, it's nothing but A union 5. Okay, it's an empty set. It's nothing but we know that it is A. Okay, so same way A intersection union is nothing but A. U. It's nothing but A. A intersection union is nothing but whole set. In that intersection, when you take it, A only we will get. Okay, this is called as a identity law. Okay, so domination law A. I'll use some other color. So domination law is nothing but when A union universal set. Okay. So it's nothing but U itself. Same way A intersection 5 is nothing but 5. Okay, this is domination law. Same way idempotent law A union A equal to, we know that it is A. Same way A intersection A is nothing but A. Idempotent, you can remember all are A with respect to union and intersection. But domination, it's with respect to union and with respect to intersection, but universal set and 5 empty. So that only we are writing domination law. Like that you can easily remember. Inverse, so inverse everyone will know. A union A bar is inverse. So it's nothing but universal set. Universal I am writing capital letter. Same way A intersection A bar is nothing but 5 empty. So that is your inverse. Double complement only one. It is nothing but A double bar equal to A. It's nothing but it's a double complement law. Commutative law, everyone has known the commutative law. It's nothing but A union B equal to B union A. A union B equal to B union A. Same way I can write it. A intersection B equal to B intersection A. Same way. Union whatever I write it, same way I can write it for intersection also. It's called as a commutative law. Associative law is nothing but bracket only we need to change, but it is for a 3 events, set 3. Okay, A, B, C, set for a 3 events. So, when A union B union C equal to A union B union C. When everything associative, everything with respect to union or everything with respect to intersection, that is associative. Distributive, it's not like that. Union, intersection, both combination will come for a distributive. So you can easily remember it. So fully union. The full problem will be union or full problem will be a intersection. So same way I can write it for intersection. A intersection B intersection C is nothing but A intersection B intersection C. So this is called as a associative. Distributive A union but B intersection C. See here in the question itself both involved means you have to apply your distributive law. When you have a 3 events but union only means associative law. So you have to remember your law name plus the equation, the corresponding formula also you have to remember. So how can I write means it's nothing but first I have to write it is A belongs to both. So that is the meaning. So A union B, this intersection is common for both. A it's for both, no. So it is A union C. So same way I am going to write it another way. A intersection B union C is nothing but A intersection B union A intersection C is called as a distributive law. So ninth law is nothing but absorption law. So it is A union A intersection B equal to same A. Same way A intersection A union B is nothing but same A. It's called as the absorption law. So last is here. Last law is nothing but De Moivre's law. De Moivre's law we will be using most of the problem. De Moivre's distribution, association and commutative. These and all we will be using in most of the problems. So De Moivre's law is nothing but A union B, the whole bar. How can I write it? A bar, if it is union means intersection. So B bar, I can separate it. The whole bar I can separate it. The only way union will change to a intersection. Same way, A intersection B, the whole bar is nothing but A bar union B bar. So this is called as a De Moivre's law. So any question if it is asked, what is the dual of the statement means? If it is union, dual is nothing but dual. If they ask any question, if they ask dual means union will change to intersection. Intersection will change to union. So like that everything. 5 will change to 5 will be changed as a union. Okay. Universal. So same way U will change to 5. So this is the dual of the statement. So now directly we will go with the problem. I will change the pen color. I will change it. First question. So whatever we have set and loss, now we are going with the problem for that. So first question. Prove that A intersection B equal to B intersection A. Okay. So the question is we have to prove it by a set definition. A intersection B equal to B intersection A. So first I will take left hand side A intersection B. So A intersection B is nothing but I will write the definition for set. Set of all x such that x belongs to full. Whatever the full question I have to write it. So A intersection B. Okay, next step I am going to separate it. Set of all x such that intersection means what is the definition? It's the intersection we know the definition. No, it is set of all x belongs to A and x belongs to B. So I have separated and written. Now next step. So when I write it now set of all x I can change and means I can write the second statement in the first and second first statement to the second. So x belongs to B and x belongs to A. I can write it in this way. Now if I write it set of all x such that if I combine it and means I have to combine it. It is B intersection A. Okay, now I can write it B intersection A. So it is proved. Okay. So this is the way we can prove it. They are asking by a graphically prove. Same question. If I extend it, graphically prove it. If they ask, Okay, graphically prove it means, how to prove it means, we know that set A and B. So set of all A comma B means this is your set A, this is your set A, set B. So this is your set A, this is your set B. So A intersection B is nothing but this is your A intersection B, A intersection B. Okay, so same way when I draw it, set A, set set it. So, okay, I have written the same. Okay, now when I write it, intersection, when I calculate it, B intersection A also, same thing only. Okay, so both are same. So we have proved it. This is a way you have to prove it. Second question. Prove that A intersection B, the whole bar equal to A bar union B bar. Now, if we prove means take only left hand side. So first I will take the left hand side. A bar, A intersection B, the whole bar. First I will write it in set definition. Set of all x. X does not belong. This bar means does not know. So A intersection B. Okay. Next step. A set of all x such that x does not belongs to A or x does not belongs to B. Okay. So it does not belongs to both A and B. That is the meaning. Okay. Next step, set of all x such that x belongs to A bar. Because does not means if I change it belongs means it is A bar. Same way R x belongs to B bar. Okay. Next step, it's a set of all x such that x belongs to A bar union B bar. Okay. Next step, A bar union B bar. So it is proved. Why we write it intersection means it is what you have to write and only I have to write. But what is the meaning means does not. So does not means it is a meaning both. Okay. So that is why I write it R here. Okay. Next question. Third question. I'll write the question first. Third question. So that prove that A minus C intersection C minus B equal to 5. Empty set you have to prove it. So now when we prove it, it is A minus C intersection C minus B. First I will take the full question. When we take it, it's equal to, how we have to write, set of all x such that I will intersection I will write it and. So x belongs to A and A minus B means x does not belongs to C and x belongs to C and x does not belongs to B. For it's not A minus C is nothing but difference statement. This is difference statement I have written. Now when I am able to write set of all x such that, okay, x belongs to A, I will have it separate, and okay, next step, x belongs to C and x belongs to C bar. Does not belongs to C, I will write it. C bar, I will write it. And x does not belong, X belongs to B bar, I will write. Okay. So what I've done, does not belongs, I will change it as bar. So next step, when I write it, X such that X belongs to A as it is, and so what happened this C, it belongs to C and it belongs to C bar, means no, it's nothing but 5. X belongs to 5. Okay, and X belongs to B bar. Set of all X such that X belongs to A and X belongs to 5 is nothing but X belongs to A intersection 5. Okay, and X belongs to B bar. Now A intersection 5, what it is? A intersection 5 is nothing but empty set. Empty set with respect to A intersection, when I take it, I will get, it is empty set only I will get. So that I can write it, X belongs to 5 and X belongs to B bar. Okay, now when I write it, both I can combine and write it, set of all X such that X belongs to 5 intersection B bar. Okay. So it's nothing but 5 intersection B bar is nothing but again it is 5 only. So X such that X belongs to 5. So what do you mean by that? It's nothing but 5. So we have proved. We are going to prove only 5. So that we have proved it. So this is the way we have to prove it. So one more question. By using laws, we will take another 2 more questions. Fourth question. If A, B, C are sets so that using still now we have seen only set definition. Now we are going to use the laws and to the corresponding. So A union B intersection C equal to C bar union B bar intersection A bar by set identities. By set identity means by using laws, it is a meaning. Okay, it is particularly mentioned like this, set identities. Okay, so what is the meaning means by laws. Okay, we will prove it. So how to prove? First we will take left hand side. So what is the question? It's a question given. So it's nothing but A union B intersection C the whole bar. Okay. So first I will use de Moivre's law, because it is a bar when you have itself, it is nothing but de Moivre's law only. First I have to apply it. So when I apply it, A bar, I consider this fully one alphabet. A B intersection C fully I will consider as a another alphabet. So when I write it, it is like a example A union B. So A union B is nothing but A bar intersection B bar. So that way I have to write it. A bar intersection B intersection C the whole bar. Okay. This fully A, this fully it's like a union B. Okay. So like this only. How can I write it? A bar intersection B bar. So that only de Moivre's law. By which law you have to write it in a bracket? By de Morgan's law. Okay, completed. Next step, This again, you check it, again I can apply a demodulus law, only this part. So A bar as it is, A bar intersection. Again I will write it in a demodulus, B bar union C bar by same law, demodulus law. Okay, next step, how can I write it? It's nothing but, now I have A intersection like a commutative law. What do you mean by commutative law? A intersection B is nothing but B intersection A. I can write it. No? So same way, B bar union C bar intersection A bar is writing by a commutative law. A intersection B is nothing but B intersection A. So that way only I have written this. Next step, you see in this, I can write same way I can write in this commutative law, because I have to prove in the question C bar union B bar, but it is B bar union C bar. So I can write it again commutative law. C bar union B bar intersection A bar, again by a commutative law. So I have proved it. So you have to bring your answer from left to right. So completed. I'll give you one more problem. Fifth question. Again, using law itself, I will give you one more question. Simplify the following sets using set identities. Okay, the question is A intersection B union B intersection C intersection D union C intersection D bar. This is only question. They are not asked to prove. Only they simplify. They asked to simplify it. Okay, answer they are not given. So we are going to simplified way. We are going to write it. So using the laws. So we will try. Okay. So what is the question given? Full question given. So A intersection B union B intersection C intersection D union C intersection D bar. So this is the question given. First, what I will write, you check in this, it's nothing but C intersection D union C intersection D bar. I can use distributive law and make it in a 3 letters itself. So I will do it. Remaining I am going to keep as it is. Remaining question, I am going to keep it as it is. V intersection. Okay, I will use this bracket. So I am getting confusion. Okay. So now when I write this distributive law, so it's nothing but, what is here distributive law? We'll write it here by distributive law. Distributive law, what it is? A, I will write it in a small letter. The same way we are going to write it in a capital letter. Okay. A intersection B union C. So how can I write it? A union. Okay. So now A intersection B union A intersection C. So like this only. Our question now you check in the right hand side part. A intersection B union A intersection okay B. Okay, it's that way only we have it. Now when I write it, so I have to write it this way. So A intersection B union C, I have to write it. So now when I write it, it's nothing but C is common. So now C is a common. So D and D bar is considered to be a different letter, B and C. Okay. So now when I write it, C intersection, okay, C intersection, okay. So it's nothing but D union D bar. It's called as a distributive law by a distributive law. Okay. So now next what I can do it. So I can apply this. You check it. C intersection D union D bar. D union D bar already we know that it is nothing but universal set by a inverse law. So that only I am going to write it. A intersection B union okay B intersection okay. So it's a C intersection. This is nothing but universal set by a inverse law. Okay, universal set by inverse law. Same way, next you have to make it very simple. Now check it B intersection C intersection union universal set. It's nothing but what is this? What is your identity law? Identity law. I will recall your identity law. What is your identity law? Identity law is nothing but okay. So A intersection A okay some other alphabets okay. So some other alphabets it's a B we'll have it okay. B intersection universal set it's nothing but B A so intersection B. A intersection B is nothing but A intersection okay, that is your identity law. So that only I am going to use it here. So when I write it A intersection B union B intersection C. Okay. Why this? Because B intersection universal set is nothing but so anything intersection it's a universal set. So now A intersection B is nothing but B intersection A by commutative law using B intersection C by a commutative law. Same way this both it's by a distributive law what it is. B intersection A union C by a distributive law. So more than this I think we cannot again simplify it. So we have to leave it. If we simplify again distributive law we apply it, it becomes very lengthy and goes on. So I have to stop it. B intersection A union C is your final answer. This is the way we have to do it. Thank you.